Okay, solids. I've got a range on my bench here to represent some variety. I've got a block of wood, some metal here, probably made of steel, a bit of ceramic tile that you may have on the inside of your bathroom and so on. And I've just got a little jar here full of marbles. What can we say about the general properties that these all have in common? Do they each have their own defined shape? Yes, they do. They definitely have a shape that is unique to themselves, but they're not easily changed. That means that it's got a fixed shape unless we do something quite difficult to change them. So I can't really change the shape of this unless I really put a lot of effort into it to try and bend it. This, I can't change the shape unless I break it. And these marbles, I would have no hope of changing their shape unless I smashed it with a hammer. So we can say that for solids, in general, they have a fixed shape that is not easily changed. So with that said, I'll give it a tick in our table here for fixed shape. Do they have a set volume? Yes, they do. Even if I was to bend this piece of metal, it's still going to occupy the same three-dimensional space, the same volume, even if I try all this effort to try and bend them. They do have a defined shape. Same thing here, I could cut it, but it'd still be occupying the same three-dimensional space. And same with these marbles. So we can say that for volume, solids also contain a fixed volume. Whoops, my bad. Forget this check mark, I ticked the wrong box. Are these compressible? Not really, not in the traditional sense. I can't press on this piece of ceramic tile and get it to change in volume. I can't really press on this and get it to squeeze or anything like that. I can't make it in a smaller form factor without it distributing itself somewhere else. So if I was to push on the metal, it might bend the legs outwards, but it wouldn't really get three-dimensionally smaller. So therefore, solids are really hard and they're not compressible. So we put a cross in our table for this last column of our table. Now we're going to move on to our next material, which is liquids, and please ignore the first tick box in that corner that I put in by mistake. I forgot one more feature to talk about, is that the fact that solids, they do have a defined shape and volume, and they're non-compressible, but you can't really pour solids. Like, I can't really pour a block of wood. I can't really pour this ceramic tile unless you have them broken down into small enough particles that you could then have one container of them and pour them into another. So just like I have this collection of marbles in front of me, you could have a jar full of salt, which is solids. You could have a jar of sugar, you could have a jar of sand, and those are easily poured, but only because they've been broken down to very tiny particles which can then flow over each other. But in general, solids cannot be poured.